So for those that are out there, welcome aboard. John, did you want to introduce Carolyn, or should I?
Yeah, go ahead, Claude.
Okay, so thank you, everyone. Hopefully we have a few more join us. So today it's my privilege to welcome our guest speaker, Carolyn St. Ange. Her background is civil engineering, but she's a senior evaluation officer with the Canadian Construction Materials Center with the National Research Council of Canada. She's worked for 20 years in developing protocols for evaluating the performance of innovative products and systems in compliance with Canadian building codes. So Carolyn is experienced in conducting performance assessments of innovative materials and certainly alternate solutions to building codes, and in providing verification that a product conforms to a recognized standard for the benefit of the manufacturers, certainly the regulators, and for health and safety concerns of all Canadians. As an evaluation officer, she's managed projects dealing with thermal insulation, waterproofing membranes, sheathing membranes, fenestration, and a few structural products. Prior to her career at NRC, Carolyn provided consulting services related to performing failure investigations on the building envelope. Again, I'd like to take this opportunity to welcome Carolyn to our group and to our webinar series, not only as well as a well-respected professional, but also to her commitment in improving the housing and building sector. Again, thank you, Carolyn. Over to you.
Thank you, Claude, and thank you, John. I would like to first express my best wishes for the new year to all your group. I hope that you are in good health and that you are off to a good start, a great start in 2021. So I'm glad to present today on Windows. So let's start right away. I have divided the presentation into 4 sections. The first one is related to Windows being an integral part of the building envelope. Second section will deal with general design and main components. Section 3, this is the core of the presentation. I will explain the National Building Code 2015 requirements for Windows. So I will go over the window performance, the energy requirements, and the selection and installation requirements. At the end, I will do a very quick overview on Energy Star rating. So for this first section, I would like to start by putting into perspective the environmental loads that the building envelope is exposed to, because windows are part of the building envelope. So it's important to understand the environmental loads. This is a figure that shows the climate and nature loads over the building envelope, the roof and the wall. I'm talking about the section above grade. So building envelope is exposed to snow load, as you know, wind-driven rain, temperature variation, wind, solar radiation, salt sea air, and so on. But the building envelope is as well exposed to induced loads by occupants, such as moisture diffusion that goes through the building envelope. This is the same thing with windows. Once installed within the building, within the wall, windows will be subjected to the same climate and nature loads. And we are expecting that the window will resist ingress of precipitation, resist wind loads, will control air leakage, limit heat loss, and so on, control solar radiation, resist force entry, etc. At the end, we are asking that we can see through windows, so they must let natural light in. So we are very demanding on the window systems. So let's start section number 2, where I will go over window types and the main components. I'm showing here a figure, a very simple configuration of a window, because I will use a lot of the terminology of the window through my presentation, sash, frame, glazing, and so on. So just to as an introduction, I'm showing here, this would be a casement window with the frame. So I'm going over the frame. This would be the sash that hold the glazing unit, and the frame, of course, is fixed to the rough opening of the wall. The window types, as you know, beside fixed window, there are operable windows available, such as from left to right, casement, awning, hopper with hinges as well. Awning and casement have hinges, single and double hung, which slide vertically, and the horizontal sliding window. I've added at the end of each of these types an acronym, which is actually important, because when you look at a window listing, you will see most of the time only the acronym used at the end of a rating. The main components of a window, the structural components are the sash and the frame. I'm showing on the figure here a casement window made of PVC, and the frame will be this part here. I've highlighted it in green. And the sash is highlighted in yellow, which is separate from the frame by weather stripping, because this is a casement window, it's an operable window. So the sash is connected to the frame by using hinges, and the gap between the frame and the sash are sealed with a gasket. There's also a glazing stop in this design of casement window. The glazing stop I just highlighted in pink, and it's a profile that is clipped to the sash to retain the glazing unit. Sash and frame can be made as PVC, wood, glass fiber, metal, or any composite. And I just wanted to highlight as well that when the windows, the size of a PVC window reach a certain threshold size, it is important that the window has reinforcement within the sash and the frame in order to limit the deflection, so in order to meet the deflection requirements. This is an example of showing green reinforcement. This is the reinforcement that would be inserted within the white sash or frame profile. Instead of using steel, this could be made of a polymer, strong polymer material, and would lower the risk of issues of thermal break. A frame can come with an extension. On the left side, I'm showing a cross section of a PVC window. This is the frame. This whole part is the frame, and this would extend over the wall, so it will cover or gap the air cavity between the sheeting membrane and the cladding. So it's helping to extend the frame beyond the cladding. On the right side, I'm showing, this is from the National Building Code, the requirement for self-flashing window, they should extend beyond the cladding. Another important part of the design of the window is the drainage system. Not all windows have drainage system, but some of them have. This, on the left side, I'm showing a cross-section of a window. This one would be made of metal, and it will be a casement window. And the pink arrow here is showing the possible path of water, because between the insulated glass unit and the sash, there might be a problem with the sealant here, and water can go in, and therefore the designer of the window created holes within the sash and the frame so the water can go can be evacuated out. On the right side, I'm showing another important component, which is the thermal break, especially for metal sash and frame. In this case here, this is the sash, and below it's the frame. And the black section here is showing the thermal break, which is usually almost halfway in the width of the sash or the frame. On the left side, you have thermal break here as well, shown in pink. This is in the sash, and this is in the frame of the window. Another important component of the window is the insulated glass unit. It's also called IG unit. I'm sure you've heard about IG unit. So an IG unit would include glass pane. And the glass are held in place with a spacer that is installed at the perimeter of the panes. And the spacer permits to maintain a specific width between the two panes. The spacer is in this graph, in this figure, is an aluminum spacer with a desiccant, which is a drying material to absorb the moisture that will be present between both panes. And the IG unit includes a sealant, showing here below the spacer. This is the spacer with the desiccant. And in black below it, these are the seal. There is seal as well on the side, the primary seal and the secondary seal, which is structural to hold in place the panes. Since most of the energy loss is through the IG unit, they created design in order to lower that issue of heat transfer through the glazing by inventing low E coating. Low E means low emissivity. This figure on this figure, you can see the low emissivity coating represented by the blue line. And in such design, you would expect that the IG unit with the low E coating would reduce the transfer of heat, infrared radiation from exterior through the interior of the IG unit, would reduce the UV through the IG unit. So by reducing the heat, it would control better the environment, and by reducing the UV, it will reduce the fading of your furniture and decor. But although the technology reduce those transfer of energy, it will let the visible light go through the IG unit. And on the interior side, the low E coating will help reduce the home heat to go through the IG unit. So it will keep the heat back inside. Weather stripping, another part of the window which is extremely important for operable windows. On the left side, I'm showing a sliding window. Sliding window would have weather stripping in the type of brush, like a toothbrush. Since it is a sliding sash over a fixed frame, this is the type of weather stripping which is designed for that type of window. For casement window, since the sash is swing over and then compress against the frame, you need compression seal. As well, there is seal between the glazing, the IG unit, and the sash, showing here on the right figure. So this is the red line is showing actually the path of air leakage between the sash and the frame. Although they are closed and locked, if the seal are not not properly installed, or are there is a defect in the seal, you would have air leakage. And finally, the last main component of the window, hinges, of course. Hinges will vary depending on the type of window, how they operate. I'm showing a casement awning and upper window, which use hinges, handles, and locking system. I would like to highlight here, this is what I was discussing with John and Claude prior to the beginning of this presentation. Casement window has a handle with a housing fixed to the frame of the window, and the interior of that housing here should have details to ensure airtightness. You can feel if it's not right, or there's a defect, you can feel draft of air if you put your hand over that housing. Sliding window would use rollers, latches, and locking system. And on the right side, I'm showing a hung window with a different balance mechanisms. So before we start section 3, which is the core of the presentation, I'd like to know if you have any questions.
Actually, I have a question. And the question is, I noticed in some cases manufacturers are advertising these solar films you can put over for higher R value, and for sun beating in, so you can control your sun in the rooms. Does that have any really bigger R value on windows?
John, I'm not sure what type of system you are referring to. Is it something which is added on the exterior side of window, or is it integrated within the window?
It's an add-on.
It's an add-on. I'm not sure if it's going to be, it may help, but when the window are tested, window is tested with a frame, sash, and glazing. So in principle, the rating that you get from a window does not come with any added system. So
okay, yeah.
So what you are saying, unfortunately, you won't have any rating with that component added on the exterior side of that window. You will have only the rating for the window itself, frame, sash, and glazing. But adding something on the exterior side, you would reduce the UV radiation going inside. So it might help, but I guess it depends on the system. Not too sure the type of system you're talking about.
Okay. We had another question. Can you add that the older windows for better R value? I'm trying to get from Elaine. Claude, what's the Elaine here? Trying to.
Yeah, I believe what she probably is indicating, she says, can you add that to an older window? So I think she was referring to your
all my plastic stuff. Yeah. Okay.
Your exterior film membrane.
Yeah. So what happened, Carolyn? I was at a couple First Nation housing conferences, and there's people, and I would call it flogging this film you put over their windows for better R value and better sun. And I know that we got a lot of inquiries from people want to know if that had any real purpose. And I contacted the manufacturers, and I suggested that, there's a lot of questions, and that they should go to CCMC for a testing so that we know exactly if this thing's working. And they never really followed up, or they sort of like disappeared. But
that's the thing, and there are so many claims on so many things, but until you have technical evidence, sound technical evidence that it's improving, it's providing, it's contributing to the energy rating of the window, it's hard to tell. A film by itself has no thermal resistance. So it has to have a technology in the film so it will deflect the heat. It's really, there's a need for testing that type of product to make sure of that performance. Until you see the evidence, it's really hard to tell.
Yeah, okay. All right, we go on to part 9 now, I guess.
Okay, so let's start with section 3 of the presentation. In this section, I will go over the NBC requirement. So I'm talking about NBC 2015, part 9 only. We'll explain the performance classes and grades, the window overall performance, physical tests, auxiliary tests, and thermal characteristic requirements. The energy requirements will explain the window selection and quickly over some installation requirements. The National Building Code requires that a window be tested in compliance with this standard. It's a very long name, but in Canada, we call it CSA A440-1111 is for the edition 2011. This is the edition which is referenced within the National Building Code 2015. And the title is North American Fenestration Standard Specification for Windows, Doors, and Skylights. It has been harmonized early in the 2000 years. In 2005, I believe the first edition of this harmonized standard with US and Canada. Although they say harmonized, when you read the standard, you will see some table specific for USA and some table specific for Canada. That's the way it is. So the code requires that the windows be tested in compliance with that standard. And the code as well says that the minimum level of performance must be class R. I will explain what this is all about. There are 4 performance classes called R, LC, WC, and AW, for which the minimum design pressure and criteria to meet are defined in relation with the window type. So let's have a look on what this is all about. Performance classes, there are 4 performance classes. And from R to AW, this would be for less stringent load applied to buildings to more stringent load applied. So R would be for 2-family dwellings, 1 or 2. SC would be for low-rise, mid-rise dwellings. And CW for low-rise, mid-rise, but with higher loadings requirements. AW would be for high-rise and building to meet increased loading requirements. But these are an indication of the level of performance. They must be seen as guidelines. So what does mean performance grades? The performance grade is the new classification system. In the past, I guess some of you may remember the classification A, B, C, A3, B3, C5 for air leakage, water penetration, and structural test. Now it's changed since 2005 for gateway performance. It's called a performance class, which has a minimum performance grade. And in order to determine what is that minimum performance grade, you need to have the product tested in compliance with CSA A440 edition 2011. So the product tested has to meet all the requirements related to that performance class and minimum performance grade. The window product that is tested in the lab to be assigned a performance grade and performance class will be tested, of course, with a specific size, and any other product of the same construction and with a size lower than the one tested will be assigned the same performance grade and performance class. So it's important here that when you read a window listing and you see the performance grade and the size of the window, but on the side, on the construction side, you receive a window which is bigger than the window for which the assessment to the standard has been done. You should not accept a bigger window because the performance has not been assessed for that bigger size than the one tested in the lab. The table below here is called the gateway performance. This is the standard CSA 440 says in terms of minimum performance to meet. So they have divided the minimum performance into 4 performance class that we just discussed. I'm going to move back here. So these are the 4 performance classes stated here. And for each of these performance class, they have identified a minimum performance grade. So 15 for R, 25 for SC. And this performance grade means that if this is the performance grade, the window has been tested, the window will have succeeded, tested, done with very specific pressure. And the pressure used during the testing is based on that minimum design pressure. In this case, I'm looking at a product performance class R. The minimum performance grade is 15. The minimum design pressure will be 720 Pascal. In imperial unit, it's 15. So you may have noticed that the 15 here is linked to that performance grade. So 25 here, it's 25 and 30 and so on. So this means if I want to buy a window that is on the label, it says minimum performance grade 15, then the minimum design pressure of 720 Pascal has been used to do the test of the window in the lab. And by the test, I mean the structural test, which will use 150% of the design pressure to do the structural test, and in the minimum water resistance pressure test used will be for the first case, the R with the minimum performance grade 15 would be 140, which is 15% of the minimum design pressure. This table is within CSA A440. And I found that it's a standard which is fairly long, relatively complex to follow. There are so many tables, so many requirements. So someone who is very interested in understanding those ratings, you almost need to have that standard and a copy of the window selection standard as well. I will discuss that in the following slides. So in order to meet the CSA A440, again, everything is linked to the National Building Code. The code says windows must meet CSA A440. And CSA A440 includes multiple tests. The primary performance tests are the following: structural test. So you have uniform load deflection test, uniform load structural test at 150% of the design pressure. And the criteria they look for is the deflection and deformation of the sash and frame. There is water resistance test, of course, with specific pressure applied. The criteria is no water penetration. There is air leakage test at very specific pressure. And the criteria here is A2, A3 or fixed. And actually, they kept only that from the past. I'm showing here in these tables, these are excerpts from the CSA standard A440. And these are the air infiltration and exfiltration level for windows in Canada. So depending on the performance class that we just discussed, if it's a performance class or LC, and it's an operable window, then here are the minimum level of performance that the window must meet, A2, but it can be A3, and this is showing how many liter per square meter of water of air infiltration or exfiltration is possible. Besides structural water and air leakage test, there is ease of operation test, and there is resistance to forced entry tests that are done on the window as well. And multiple auxiliary tests are as well, such as the sash vertical deflection test, vertical concentrated load, thermoplastic corner weld test, and so on. There's a long list. And in terms of durability, the material of the sash and frame must meet a few standards. For example, vinyl compounds for PVC windows must meet an ACM standard. If there is a wood sash or frame, the wood treatment must meet some requirements. Glass fiber as well, the coating. Of course, corrosion resistant requirement for steel. The insulated glass unit shown here must meet a CGSB standard, and so on. So the list is very long. And in addition, there is the weather stripping, hardware, reinforcing members that must meet the requirements of the standard. So at the end of the day, when the specimen tested in the lab has met all the applicable requirements, then a rating can be assigned to that tested window. And this is, I will try to explain to you how the window must be classified now. They mentioned that the window on the product literature, the window has to have the primary designator. What does it mean? It means that you have to the manufacturer has to specify in its product literature the class, so CW, PG, performance grade, and the size of the window tested, and optionally the operation, the type of window. This is an example of a fixed window. So this means when you see this on a product or on a window listing on CSA Group, for example, you will see the glass performance, the performance grade, and size tested. Again, I mentioned that earlier. If you see on-site a window that comes with that product literature, but the window size is bigger than the size shown here, then there is a problem. You should refuse that window because you will not be sure that it will meet the requirement of the standard. The standard allows for additional information to be published in relation to the primary designator, but the primary designator is mandatory to be published. The secondary designator will have information about the positive design pressure, the negative design pressure, water penetration resistance test pressure. So they will say, how much Pascal it has succeeded, can air infiltration and exfiltration level that the window has met. So in this case, this is a fixed window that has met that performance grade with this size. And they are specifying the secondary designator by saying the water penetration resistance test has met 580 Pascal, which is advantageous for a manufacturer to specify, because if it just shows this means that the window has met the water penetration test at 480 Pascal. But if I ask the lab to continue to increase the pressure to see, what will be the limit pressure is window will be able to sustain the water penetration. So they increase the pressure level, and they determined that window was able to meet the water penetration test at 580. So its performance is a bit higher than the pressure linked to the performance grade assigned to that window. And I don't think I've mentioned, but you can see designator in metric units or in imperial units. So on the first line here, I'll show the imperial units, and the second line is the imperial unit. So PG60, this is in pound square foot, and 2,880 is in Pascal. This is an excerpt from the website from CSA Group. It's a window listing. I don't know if you can see, I know it's very small, but it's just to show you how it looks on a window listing. I've highlighted here in red the primary product designator, and I've pointed out here an example. This is a casement multi-point lock series. It's double glazing. And you see here how they spell out the primary product designator. This is in compliance with the requirements of the standard. So they start with the class CW, followed by the performance grade 80. This is in imperial units. The size test in metric and in imperial, and followed by the type C. So C means casement. On the right side, this would correspond to the secondary designator, which outline the positive and negative pressure, the water resistance, and the level of air leakage that the window has reached. Any questions so far? Maybe I can stop a few seconds if you have any questions. It's good. All right. So the National Building Code also includes requirements regarding heat transfer performance of windows. As mentioned earlier, there is a large percentage of energy lost occurring through windows. And heat loss will occur due to different modes of heat transfer, by conduction through the frame and the sash, by convection through the gap between the sash and the frame, or by radiation and conduction through the insulated glass unit. The code requires that under table 973P that the window meet the maximum U value or meet the minimum temperature index I. This table summarizes the requirements within the National Building Code. And it is showing that for windows, depending on if the window is exposed to cooler temperature than -30 under the 2.5% January design temperature, then for this type of outdoor condition, the maximum U value must be 1.7. What does it mean, maximum U value? U value is the reciprocal of thermal resistance. So if you speak about U value, it means the transmittance, not the resistance. It's the opposite. If you want to have an idea of what would be R value, the corresponding R value for a U value of 1.7, you just calculate 1 divided by 1.7, and this will give you 0.58 or R 3.3. So the lower the U value is, the better performance the window has. The code requires either maximum U value or minimum temperature index. In that same area, the minimum index temperature would be 77. This is a calculation of the temperature of the frame minus the outdoor temperature. So it's a temperature difference between the interior temperature of the frame versus the outdoor temperature over the delta T, the temperature between the interior air and the temperature of the exterior air. So it's just a ratio. And here, compared to the U value, the higher the index is, the better the performance is. The code also requires that thermal break is installed within sash and frame of metal frame. I've discussed that earlier, so it's just to mention that this is part of Article 9733 from the code. Section 936, as you know, is related to energy efficiency, and the code requires under table 932.7 that windows meet the maximum U value shown in that table or meet the minimum energy rating. Windows must be tested in compliance with CSA A440.2, which includes A440.3. So once tested, then you have the result, and you have to compare if the results meet the criteria shown in this table. So, for example, if the project is located in zone B, 7B, then the maximum U value must be 1.4 for the zone B. And the energy rating would be 29 for zone 7B. Any questions on these ratings?
So if I was a community in the Northwest Territories, I would be going for a zone, I'm just trying to make that out, a zone B as part of my technical specifications that I would ask for my windows. Is that correct?
Yes.
Okay. So if somebody's going to tender a contract, they should have this in there as part of their technical, and because you don't want a contractor sliding zone 4 windows into a zone 8. But if you don't specify, you're going to get zone 4 windows in zone 8.
That may happen, yes. So it's very important that the zone has been identified and that you have technical evidence that the product has been tested in compliance with the standard I was talking about. It's highlighted here in red. So it has to be tested in compliance with CSA A440.2.
Okay.
And the U value must meet the criteria for the specific zone.
Yeah, and I think the challenge for a lot of communities, because when they go to build a home, I'm just not sure how many have technical specifications. And if you don't specify zone 8, you're going to get zone 4 because zone 4 has got to be much cheaper than the zone 8 window, I would think.
Yes, exactly.
That's a big difference.
Yes, because typically double glaze unit with argon gas, with warm edge technology as the spacer, with all those high performance technology, it may be able to meet the criteria for zone 7B and zone 8, but it depends, depends on the quality of the overall window. So you have to make sure it has been tested and it meets. A triple glaze would be more, it would be more safe to say it's going to meet. But you can have a double glaze as well, but it has to have all those components I was talking about earlier that has those high performance in order to meet and A. So make sure you have those ratings from the lab that did the test in compliance with CSA A440.2. Any other questions?
Go ahead, put it on the chat.
Sorry, John?
Oh, Claude, do you want to read the chat questions? Oh, all right. So go ahead, Claude, you're there?
Okay, I'm back on, John. Yes. Earlier, there was a question about sizing windows. And it was in, I think, respect to the actual size versus the rough opening size. But I think from more of a technical or construction point of view, typically windows can vary from manufacturer to manufacturer. And the actual sizing for an opening to allow for that window to be installed generally is going to be slightly larger. And often most manufacturers would indicate what the rough opening size should be or is recommended for that particular window. Any comments, Carolyn?
I'm not sure if the question was, if the question is regarding the proper size for a type of window, like the type of operable windows versus its maximum size, or for the project itself, you know, depending on where the window is going to be installed, with what type of building. So I'm not sure of the question.
Well,
but the size of the window usually is the contractor will go on the construction site, will measure the rough opening, and determine what is the proper size of the frame to fit in the rough opening. So I'm not sure if this is the in relation to the question.
Yeah, I think it is. I think it's part of the. I think it's part of the question and certainly part of the answer. I guess as an architectural designer, I've always looked at it that if I was designing windows for a house or a building, I typically would look at certainly the criteria that we're looking at here, the performance requirements, and making sure that it does meet the CSA A440 standard, but also the fact of what are the common window sizes that manufacturer would use or recommend that they actually can supply. So I think
there is the manufacturers can fabricate any size. They can fabricate any size that you want, and they will in principle they will specify, if let's say it's a PVC window and you want a big window for your living room, they will say that some reinforcement bar are required within the sash and frame for your window. They will say you need maybe a more efficient type of hinges because of the size of the window. So they will, the manufacturer will inform you of the necessary features of the window in order to make sure the window will perform correctly at that size. So, but again, what is important is that the classification rating that you will get from that window, make sure that it is matching the size of that window. So what you have on site is a size which is equal or lower than the size that has been tested. Usually manufacturers do not deal with homeowner or builders or contractors. It's the supply. It's a second party that is involved. There's a lot of intermediate parties involved between the owner and the manufacturers of the window. Usually, the supplier of windows will have their own installer, or they will sell you windows and you will contract with a company to install those windows, but it will be your responsibility. The installation will be at your risk.
Good. Thank you very much.
So if there are no further questions on energy requirements, I will move on to the other part. Unless you have other questions, Claude?
We're good so far.
Okay.
Proceed.
Now, with respect to window selection, the National Building Code requires that the windows are selected following the CSA standard A440S1-09. This is stated in NBC 2015 under Article 9743. So the code says you have to select, windows have to be selected in compliance following that standard. And the performance grades for Windows shall be selected according to that standard, so as to be appropriate for the conditions and geographical location in which the window will be installed. At the end of the day, you want to ensure that you will select a window with a design pressure that will be equal or higher than the specified design pressure from A440S1. What does it mean? Let's go over an example. So just as a reminder, I've copied that table I was talking about earlier. This is from the CSA A440 standard, which shows the minimum performance class, minimum performance grade, minimum design pressure, and these are the pressure used for the primary tests, such as structural, water, and air leakage. The CSA A440 says these are the minimum, but a manufacturer can decide to have his product tested to higher performance grade. Performance grade can go from 15 to 100. So pressure can be much more than what they are showing here. This is just a gateway performance. So again, this says that window selection requirement under CSA A440. This is a shown in CSA A440S1. I will quickly go over the different steps. There are 10 steps to follow. It starts on the top here with building information. So what do they mean here? They say you have to specify the location. Let's take an example. Let's say the building is in Churchill and the height of the building is 15 meters. So you will write Churchill, the tank is open, the height is 15 meters. Get those values here, which relates to the wind pressure, driven rain, only wind pressure, and so on. They say go to table A1 to get those data. Actually, you need to have a copy of CSA A440, CSA A440S1 to understand all this, because you need to flip from one standard to another and look at those tables. So let's go to table A1 here to get those data. So this is a copy of table A1, and our case is building in Churchill. So I'm looking at the location Churchill, and I will take those parameters here in relation to Churchill. I would go back to that checklist and fill in the blank. So I won't go through all this, but this is just to show the idea how it's supposed to work. So once the step 1 is done, you go to step 2. They require performance levels. Step 2 says you have to fill out this summary table. There are step 3 to 10 to follow, and it's all explained under here. So In order to fill out that line in the table, you have to follow step 3. So if I go to step 3, it says consult CSA A440. So you just consult CSA A440 and get the minimum rating. So you will write it down here. Then you have to go to step 4, water penetration resistance. How does it work? You have to determine the specified ring rain pressure by going into table 1 and 2. We said in our example, it was an open terrain, so we go to table 1. Table 1 says, this is the specified drain-driven wind pressure, and you have to know the 1/10 pressure and the height of the building to get that value, 463. And so you fill the blank and continue with the table. And step 6 is positive pressure from snow load. We are talking about a window in a wall, so there's no snow load. So you just put 0 and you move on with the other step. Sorry, I'm just gonna go to step 6, 7. Sorry, I'm going to go back to positive pressure wind load. They say go to table 3 because it's an open table, our example. So I go to table 3. I have to go back a little bit. Okay, table 3. This is table 3. So I have to know the 1/50 hourly wind pressure that comes from the earlier table, A.1. The height is 15, so I get that value. I go back to my checklist and I include it there. Then they say how to calculate the specified wind load. You just have to multiply the value that you got under step 5 multiplied by 1,000, so you will get 1,680 Pascal. What does it mean at the end is that your design pressure must be equal to or superior to 1,680 Pascal. So at the end, you go to the table in CSA A440-11 to determine what will be the performance class for a case of that pressure of 1,680. This is a copy for the table in CSA A440. So what we are trying to figure out here is if I have a window tested by CSA A440, what will the performance class and design pressure will be required in order to comply with that example, that project where the specified design pressure is 1,680. I look under here and I found that for performance class, there is a design pressure here of 1,680, and the water pressure resistance test minimum pressure is 2,260. But our example, when we looked at the different tables and we found the parameters, we found that the driven rain water pressure must be equal or superior to 463. So we cannot take this performance class. We have to go select a higher type of window, a higher performing window. So we have to go down to the one that has a water penetration resistance test done at 470 in order to meet that minimum specified pressure. With respect to the design pressure, it will definitely meet the design pressure of 1,680 Pascal. So the standard, the standard for user selection is telling you how to determine the specified design pressure, considering the location of the building, the height of the building, and all the different parameters in terms of load associated to that project. And then you have to select a window which will have a performance that will meet those specifications. So this is what I'm trying to show here. Once you know the specification, then you pick a window that will have the proper ratings in order to meet those wind loads, pressure. Any questions? The last one, this is, I'm almost there. I'd like to go very quickly over the window installation. The National Building Code requires that the installation conform to another standard, which this time is CSA 440.4. It's the window door and skylight installation. So the code says it should install plans with that standard, but the protection from precipitation shall conform to NBC 927. NBC 927, there is a little bit of information with respect to flashing, with respect to sealant, and I'm showing a few figures here. As you know, the head of a window, as an example, you must have a flashing if the height of the distance between the head of the window and the soffit is more than L/4, and L will be the width of the soffit. I've shown this figure earlier. This is code requirements with respect to the drip and the slope of the self-flashing windows, etc. So there are a few details in the code in order with respect to precipitation, protection from precipitation. There's also requirements that says the continuity of the air barrier system and vapor barrier with the window frame. I've pulled out here a figure that shows a case where this is the typical case where the poly is the air barrier and the vapor barrier. And this is showing that the top of the window, which is the frame, this is the frame of the window. Sorry. This is the frame of the window. It shall be connected to the poly, which is acting as the air barrier and vapor barrier. So any means can be used, polyurethane foam, a system of caulking with backer rod, and so on. And finally, other ratings. Energy Star, I'm sure you've seen Energy Star label on different products. They refer to different ratings. U value is the same thing as U factor. This is the rating that is given to a window based on how much heat loss it allows. Solar heat gain coefficient, the fraction of solar radiation that is emitted through the window. Energy rating, we discussed that earlier, and visual transmittance. This is the measure of how much visible light passed through the glasses. As a summary, some factors, what you need to look for compliance with NBC 2015, technical evidence that the window meets CSA A440. You need to have the primary designator, which includes the performance class and performance grade. You need to have U value or temperature index that meets NBC 9733, U value or energy rating that meets 936, and the window should be selected per A440S1, and the window should be installed per A440.4 NBC 927. And I just want to end by saying that the design that improves thermal resistance is mostly in the glazing unit. There should be a low-E type of technology, inert gas in it, warm edge, spacer technology. The spacer width is important as well. And of course, a glass unit would improve the thermal resistance of the window. If it's a metal window, the sash and frame should include thermal break. And at the end, window installation is a very important factor as well. So this is it. Any questions?
Any questions from anyone or chat? Or I know a couple comments. I know that some of that information we got to try to repackage and get them into some of the communities in the north. Again, I'm just recalling, people who are doing the technical specifications aren't technically specifying the windows they need in their communities. So somehow we have to get a summary of that information and put it forward. And then,
yeah, John.
Go ahead.
Yeah, Claude here. Yes, John. I think in a lot of cases, I think you kind of hit on the item earlier that probably what we're seeing is a lot of windows that are designed for, we'll call it the more temperate climates of southern Canada, end up going north into that colder climate, and therefore certainly it has a great huge significance on the not only the quality of the window that they're getting, but also the performance.
Yeah, because if you don't specify in your technical specifications, you're going to get the lower grade. And why wouldn't you? If I was a contractor, if there's no specifications, I'm going to throw you windows from Sarnia that in fact should be much higher quality because the price point.
Of course, yes. And I would say even if you may ask as well the manufacturer or the supplier to provide technical evidence. Manufacturer may say in his literature is the design performance, the primary designator, it will show all the information on the window ratings, but you may ask for technical evidence as well. Or a CSA group listing.
Yeah, no, I think that's important because, again, we know through our experiences that contractors will provide for many of the Indigenous communities stuff that wouldn't make the grade off reserve, but they push it on reserve. Again, we have examples of furnaces and heat exchangers and, and I assume windows are the same case. So it really becomes, I think the onus is to educate our members on what, in fact, how they should order windows. So that's one of the biggest complaints we get.
Yeah, it's definitely there is a need to make sure of the performance and the quality as well of the window. There are so many aspects. I don't know if acoustic performance is of interest, but some windows, you install them and you can hear anybody outside talking. Sometimes it's some people prefer to have very good acoustic performance. And when you look at a cross-section of a window, and I've shown some cross-section with lots of walls and small chamber, and some windows have almost nothing. Some of them are poorly designed, and it's cheaper, of course.
Yeah. Yeah.
Carolyn, I basically have a question regarding when you're testing and determining the insulation or performance factor of the insulation value of a window, do you base it only on the glass, on the frame, or a combination of
No, it's the whole. It's the
package.
whole window.
Okay.
It's the whole window. They put thermocouple on the glazing, on the sash, on the frame.
Thank you.
So it's the whole unit.
All right, if there's no further questions, I did get about 5 notes to send the video out, so I think the response participants have been quite good. Carolyn, again, I'd like to take this opportunity to thank you to shed more light on Windows, and somehow we got to try to repackage some of this information and get it out to everybody. And I'll work with trying to find some documents. I know you mentioned there are some we could send out, so I think that'd probably be the best thing at this stage. So there's no other comments. Thank you, everyone. And our next webinar, we will send a note out. It's I think it would be Pile Foundations in a couple weeks.
Okay.
All right. Thank you, everyone.
All right. Thank you, guys. And take care.
Yep. Thanks, Alan, for the comments.